So my name is Alex, and that's Jeremy. Um, if you looked at the program, you would note that they switched our bios. In reality, I'm Jeremy. This is Alex. I've been at Red Hat for quite some time, and this topic is near and dear to me. If you're here for the full 2.5 hours, you will be disappointed. I don't think this topic needs a full 2.5 hours, but if we've got a lively discussion, we can go. So uses for CVE root cause mapping. Before we get to this next slide, I kind of wanted to like state why this is kind of near and dear to me. I think, I've talked with a lot of the other P-certs that are out there over the last couple of years. We are all aware of the fact that the volume of CVEs continues to increase year over year. New software hits the market every day, and ultimately CVEs represent mistakes in design, in my opinion. But the baggage of carrying around underlying weaknesses for long periods of time adds to that CVE volume unnecessarily. I also sit on the CWE board. There are a bunch of brilliant people on that board, but I would say that one of the challenges, and I represent kind of a unique position on that board, it is very academic at times. I don't care about the academic part, so I'll just be blunt and be honest on that. What I care about is using the data for something useful. Like, how do we use the CWE data that we have to improve our products? So I don't think anybody has yet figured this out. Otherwise, I would have found it because I've Googled on this quite a bit. And like I said, I've talked to other P-certs. So Alex and I came up with some suggestions that we are going to present. And then we want to do a little, instead of like a traditional Q&A, we want to hear from some of you in terms of how you might use some of this data, or maybe how you are using some of this data. So next slide. All right, so what problem are we trying to solve? Talked about that a little bit. Methodologies and challenges, the benefits, and then we can get into that discussion on what everybody else is doing. Next slide. All right, so as a software vendor, we talked a little bit how the volume continues to increase over time. We're always finding ourselves fixing CVEs. It's not really scalable. But I think the other problem here is, like, how do you prioritize kind of an overload of information? And I put DASTI here. DASTI is not necessarily a source of weakness, but when you can consider the amount of information that goes in front of software developers, it can be noise. Right? So we have a lot of noise in front of our software developers, and I get to be the bad guy most of the times at Red Hat and saying, okay, here are your priorities. You got to fix all these vulnerabilities, and I'm not very well liked. So if you put a bunch of weaknesses in front of them as well, and a bunch of scanning results, then where do you find time to get it all done? So part of our methodology that we'll go into in a little bit is not just saying, great, we have CWE data, but it's how do you make that data useful? So sometimes we're just collecting data for the sake of collecting data, and that's kind of a problem. And so this is, again, we want to address that. Is the software secure? If you're a consumer, if you're a customer, one of the questions that you care about is the state of your software from a security perspective. And also keeping in mind that vulnerability remediation is expensive. Right. So you're a customer and you get a bunch of security advisories every week. That's time that you have to spend patching your systems, pausing things, taking systems down, right? So it can be quite expensive. We really do ultimately want to reduce the number of those vulnerabilities. Next slide. So looking at some of the origins for weaknesses. Weaknesses are not an unknown thing. You look at the definition there. This is the underlying cause for the vulnerabilities. It exists in firmware, hardware, and contributes to those vulnerabilities. If you look at the threat models, we discover weaknesses as part of our threat models. There's of course the SAST, especially results, like just bad code in general. And I think, I was talking with somebody, I think it was somebody from MITRE yesterday about the threat intelligence part. And they're like, we're seeing more and more need for some of this data. What's driving that? I know just by being in my space there at Red Hat for the last couple of years, we've seen a lot of interest in threat intelligence. It's taking data from a number of different sources, not just weakness data, but then trying to, make some sense out of that data to determine where are our most risky components or products. What are the ones we need to be, paying attention to? It's kind of solving some of those questions. And lastly here, we've got the root cause mapping that comes in from CVE analysis, right? So we've got lots of sources. Next. So finding commonality in the data. Next slide. If you look at each one of these, you've got your threat model, you've got patterns, and you've got a focus kind of on a CWE family. If you look at kind of the way of categorizing some of those patterns within your DASTI results, these are also patterns. The point we're trying to kind of make with this is all of this can map back to an underlying CWE ID, right? We've got a great taxonomy out there, and part of the purpose of that taxonomy is helping to just have that commonality across all of those the landscape, so to speak, right? Everything from could happen to it already did happen with a vulnerability. Next slide. So I think step one, and this is, I'm taking a little bit of liberty here. Like if I was, giving direction to a particular, company or someone, I would say, okay, well, you have to make a decision and sit down and say, okay, well, we are going to blend our data somehow. We are going to, take our threat models, we're going to take our root cause mapping, and we are going to use the same identifiers, and we're going to operate off of that same data, that set of data, right? So there is work involved in actually mapping between and blending some of that data from all of those different sources. But the end result is if you have like if you built it upon that CVE taxonomy, you can do some really cool things with that data, that CWE data, and the counts and the mapping to components. So how do you filter through that? And this is really the heart of kind of what we wanted to get at. Alex has quite a bit more fun digging through the data, so he is going to talk through the next couple of slides.
Thanks. All right, thanks. Can we go to the next slide? Great. So we wanted to use some practical examples to kind of discuss and illustrate this point. So one of the things that's great about CWE is that it has a flexibility, right? So because it maps things from a high level to a low level, you're able to, based off of the audience that you have, or the context that you have, whether you're looking at a framework or you're looking at standards, but whatever it may be, you have a choice of granularity. When we looked at some of our own data, right? So to see, for example, from the year of from last year, from 2024, what were the most common CWEs and the most impacted components for vulnerabilities that impacted rel, excluding kernel. This was kind of the list of the, let's say, the top 5. Now, the CWEs you see here are pretty much all classes. I think 1 or 2 might be pillars. So they're slightly higher level. The real objective here isn't so much to necessarily talk about exactly what was going on, with WebKit GTK in 2024. It was more to illustrate the point that, as you'll see on the next slide, but you're able to map things depending on the audience level. So here, this isn't the kind of CWE data that you would necessarily pass to engineering, because it is kind of higher level, right? Memory buffer errors on its own isn't necessarily something that's specific enough to engineering to help make it actionable. If we look at the next slide. Yeah, of course.
So the other thing I would say on this is, as an option for presenting this information to engineering, instead of saying, hey, here's a specific, instance that we found where this memory issue, and you could get to the lower level CWE for that, you can present a bunch of data to them and say, collectively within this particular component, this is a weak area in general, right? So you need to do something about that weak component.
Yep. On the next slide, you're seeing the exact same things, but basically with a more specific CWE mapping. So this is where it becomes, let's say, more actionable at a lower level, because instead of just saying, for example, something like memory buffer errors, you can start saying, yeah, you have out of bounds reads, you have exposure to sensitive information, to an unauthorized actor. Basically, the point is, because of this tiering that you have with CWE, depending on the audience, again, that you have in front of you, you're able to go into more or less detail, but since it is all mapped, you don't necessarily lose the thread, right? So you know that you're still talking about the same thing, even if it's at a higher level, because higher level CWEs then map to lower and lower level CWEs. So you can be sure that like there's a thread that's keeping everything kind of tied together. In fact, on the next slide, when we talk about it as a connecting thread, so the point is kind of this, right? Like I was saying, memory buffer errors can map to things that are a little more specific, out of bound reads. That might be more useful to engineering, right? There are CWEs out there that are like insecure configuration, which on its own is a little vague. That might be fine if you're trying to do a more high level report and you want to kind of just have a general overview of what's happening, let's say with your products. But if you're going to pass something to engineering and you say, we want you to fix something, it's helpful to have something more specific than, yeah, take a look at this component. It has an insecure configuration. That can mean a bunch of things, right? And the other big advantage, because like we'd already mentioned, right, the standardized and common language. So essentially the fact that because of these different tiers of mapping between different levels of specificity, you're kind of guaranteeing that even if you're talking at a very high level, using specific terminology, mentioning specific kinds of CWEs, which are maybe classes, right, or categories or views, you can still be sure that when you're then mapping those things down to like a lower level, you're maintaining a parity, so to speak, right? Like that it can't be misinterpreted because there's a limited number of lower level CWEs that could be associated with a specific topic, with a specific higher level CWE. Yeah, so I'll turn it over to Jeremy.
I want to say one more thing on both of these options here. You'll note we put 5 components, right? There was a reason for that. We could probably have listed out like all the components that go into Red Hat Enterprise Linux, for instance. That's a lot of data that's useless for engineering, in my opinion. But if you can sort through this data and say, okay, well, of all of the vulnerabilities reported, using root cause mapping, we can say these were the components where we saw most of the vulnerabilities. You're prioritizing that data set. Maybe it's 5 components, maybe it's 10, right? But the point is to, chisel away, chip away at that a little bit over time, right? And, as a product security organization, especially, you can provide that information to engineering in smaller chunks and say, okay, well, maybe focus on just these particular components. So some additional suggestions here. You really need to tailor the results to the audience, right? So if you're working with product managers, you might want to use those higher level CWEs. If you're working directly with engineering teams, engineering leads, you might want to use the lower level CWE data to be a little bit more communicative on the specifics. Also remember your upstream contributors. This is especially relevant for Red Hat, right? We're working this open source space. A lot of the components that we pull down are developed upstream, right? So, if you're trying to make a change to some of those components, you don't want to necessarily fork it internally and with, as a vendor, right? But you want to work back upstream and give them that data as well. Integrate those metrics into your development pipelines, right? There's ways of working with your pipeline teams to say, all right, maybe these are some checks that can be run as part of that pipeline work. The last thing I'll say here on this this bullet is it's not just limited to just fixing code, right? I think sometimes we tend to think, all right, well, this weakness or this collection of weaknesses in this particular component just needs a complete code change. I think the example that somebody pointed out to me from our kernel team a couple of months ago was, well, most of the weaknesses they see are specific to this type of memory management that's being done, and that's not something that's going to change, right? So you can also implement guardrails, security practices, controls. There are other things that you can work on collectively as a vendor, as a product team, to help minimize those underlying weaknesses so that those vulnerabilities, decrease over time. This is the point in the conversation. We tried to keep our portion of this fairly quick because we wanted to actually not, like I said, not do a Q&A per se, but want to hear from folks in the audience what you're doing to use CWE data. And if nobody raises their hand, I won't be really surprised because, again, this is kind of what I've seen in unofficial surveying of people I've talked with. In the back, we have another microphone.
furthest one away. You could have like moved over two more.
So that's really great, but how you leverage then CWE data to then address root cause or vulnerability class or squash vulnerability classes? And then are you looking as well at vulnerability data to then have a better conversation with your software team on, hey, these things could potentially turn into something malicious because this pattern of things are more frequent in exploited vulnerability or something else?
That's actually the intent. I think part of making this useful is not just, I mean, I could compose an email tomorrow to a particular engineering team and say, these are your top, weaknesses, right? That could be useful, depends on the engineering, your team you're talking to. You guys are, there's a second part to this, really. It was kind of unplanned, but it worked out really well. So Rogue, who just walked in the back, is giving a presentation tomorrow to talk about how to actually implement some of this data into the threat modeling and the threat research type of work that can be done more by like an SDL focused team. So intent there is really kind of tying in some of this data into maybe some of the other activities that are happening in your organization. And that may be more useful because it's a little bit more focused and it's the same kind of, it's a more simplified message back to engineering teams rather than them being hit by multiple people, right? Yeah.
Just as a semi-practical example, part of the reason why we include CWE data on our vulnerabilities is because, for example, if you're thinking about SAST, right, in a product's like build process, like in a build pipeline. So SAST will obviously come out with a bunch of CWEs, right, for a given product, a given scan. You can leverage the CWE data that you see from vulnerabilities to prioritize the list of CWEs that you see from the SAST output, which is like a feedback loop, right? So as you see things either increasing or decreasing, you can kind of understand how to better tune like your security gates, for example.
Yeah, but on that point, are you prioritizing or are you looking at specific classes of CWE or group of CWE as more dangerous than other classes of CWE, like remote code execution, memory corruption, input validation classes versus path traversal?
That's exactly why I wanted to have this conversation with the audience. Like, this is good feedback, right? Like, this is not something that we're doing at the moment, but I think that's a great recommendation.
Thank you.
The shortest part. On the talk yesterday, I talked about trying to map to good CWE data. But the nice thing about CWEs is it applies to CVEs and also internal vulnerabilities. So you can use them for everything, all classes of vulnerabilities, which is good. So my thinking was that all the data points or intersections across the DevSecOps pipeline, you mentioned SAST, but all the tools right through the bug bounty and etc. runtime, you can all use CWEs. And the idea would be that you create campaigns around classes of vulnerabilities and you go after them to eradicate those classes. That's, a very effective way. So you prioritize and then you eradicate by whatever it is. Maybe it's information disclosure or whatever the thing is. That's, and then you have a holistic view of that particular weakness, and all the tools speak the language of CWE, or you can map all the results to CWE. So that's why I think it's very, very powerful, even if it doesn't seem to be a common, mature practice yet.
Agreed. Any other comments out there? Excuse me. I guess we'll go.
Hi, I'm Jim Duncan. I've been involved in FIRST in a long time and currently, I guess, semi-retired. I don't know what to call it. I look over at Ken because Ken's been here longer than I have. This stuff is dated now, but I actually gave a presentation on this at the FIRST conference in Kuala Lumpur for an hour and a half, 2 hours. When I was at Juniper, I worked on the secure development lifecycle, and we leveraged the data in two different ways. First thing was to get fields added to the defect tracking system to track CVE labels CVSS score and CWE levels. And that gave us some information to work from. When we had specific engagements, either internal or contract pen test of a particular product, for example, I used the CWE label data to develop a 10,000-foot understanding, because if you go into a mid-level or top-level executive and talk about buffer overflow, buffer underflow, off by 1 error, off by 2 error, their eyes glaze over pretty quickly. So that wasn't useful. When you can do the higher level stuff, because you're looking at the CWE labels that crop up, you can do things like recommend that as developers desperately need remedial web security training or similar. The other thing you can do is you can champion efforts to switch over to Rust, for example, because you can take and wipe an entire category of weakness labels off the table if you can get support for that. The other way that we use this is I began with once we started accumulating enough data, I began doing an annual top 10 weakness report internal to the company. And that got a lot of attention. And to do that, you don't have to be perfect. And also, if you do that, remember that my boss, Seth Ross, thought of this. I wish I'd thought of that. He pointed out people started bargaining about, is the item in position 4 really worse or better than the item in position 8? It doesn't matter. What matters is that the weaknesses showed up in that list, the top 10, without regard to rank. And last but not least, Juniper had a practice, I don't know if they're still doing it, but they had what they called the Big Bang Day. And it was once or twice a year, engineers had the freedom to work on whatever they wanted to work on. And I exploited that to get our security champions to go fix that weakness that was over in this piece of code that everybody knew about for 4 years and nobody had the nerve to fix. Because that's the other problem I ran into with working on CWEs. Hypothetical manager-developer conversation. How did your day go today? And the developer said, great, I fixed these 2 weaknesses. And the manager says, well, that's great, but what about our stuff that we have to get done under contract for this customer? Well, I didn't get any of that done, but I got these weaknesses fixed. That's bad enough. But here's the kicker. The manager says, let me get this straight. The code was working before you screwed around with it? Well, yeah, but I think, why did you mess with it? Right, that's the hidden trap for any of this work on CWEs. It's a weakness, not a vulnerability. And it's an uphill battle to convince people that you need to fix them before they become a vulnerability. And that was one of the biggest problems that I had with it. And I hope that helps. I'm happy to share. That paper's archaic now. Kuala Lumpur, I don't remember. Do you remember when we were in Kuala Lumpur? 2018? Yes. Yes. Oh, I remember it well.
I would be interested in that paper.
They thought I was law enforcement. I was riding the escalators in the conference room, and the militia would come to attention and salute me as I went by. And I was like, this is weird.
You said a couple of things there, and I have a follow-up question for you, but you said a couple of things that I liked. It's the training bit. I hadn't actually thought about the training bit. Like some of it is just, you may not have to make a change at the coding level, but maybe you do, but maybe it's influenced by the training, right? And
oh yeah, no, we started, I had forgotten this, but you're reminding me now. There was mandatory secure coding training internally. And you were required to pass the training for one area that was most aligned to the type of work you're doing. So if you're coding in C, for example, you did the C version. If you're working in JavaScript or whatever, there were other versions. And then we flagged that in the internal records, and we did some security champions that went the other direction. They did really well on their exams and stuff.
One more follow-up question for you, and I know we have a question over here. With your report that you released, did you structure that based off of like the entire portfolio, or did you zero in on specific products?
The report, you're talking about the annual top 10.
Correct.
It was mostly Junos, but there were exceptions. If there were other schemes where stuff popped up a lot, yes. But the vast majority of this stuff were problem reports filed against Junos code. So that was where most of the report, because that was where the data was. The one downside of this, I will point out, we only had weakness labels for 1/10, maybe only 1/100% of the actual number of defect reports that were filed, because a lot of those were automated and just, routine stuff. So it wasn't a perfect snapshot. It was a snapshot of stuff that was uncovered either through reporting or external reporting or testing that identified as a vulnerability. We didn't bother with general
Right.
code.
Awesome. Okay, so while the microphone gets passed, and this may be something that's a better fit for the scope tomorrow for what Rogue is going to talk through, but I think some of our developing teams, developers are under a lot of stress right now, and with the vulnerabilities, and most of them would actually like to implement features or fix bugs, and so it's not that hard of a sell anymore. I mean, the hardest part is doing the work to collect some of this data so that you can present it in front of them and say, look, you could solve, you could free up some of your bandwidth if you just fix this a certain way, right? Like, but you have to have the data structured and you have to be able to sell that to them, and that does take a little bit of work. Again, that's why I say maybe it fits in with more what Rogue's going to talk about tomorrow. Question over here.
Thank you for your comment, because it actually is part of what my question is about leveraging the CWE data. What the people that I'm working for are saying to me is, I don't want you reporting any more stuff. Because I got the report from here about the CWE and here for the CWE and blah, blah, blah. But what I need to do is provide recommendations based off of that CWE data. So I want to be able to leverage it that way. So I'm not just saying, here's these weaknesses. So I want to be able to leverage it in more of a predictive way, I think.
Mm-hmm.
Is that something I don't even know if that's possible. Is that possible?
I think it's possible, and I think we're going to talk a little bit about it tomorrow.
Oh, excellent.
Yeah,
Thank
make
you.
sure you come to that session.
Thank you.
Any other questions?
Just a quick one. Ken reassured me it was 2018 Kuala Lumpur. The presentation's online. If you have questions about it, just ask.
Thanks.
Some of us changed, some of us not.
All right. Well, I think that was a good conversation, and it gives you guys actually enough time to go do a bio break before you bounce to the next session.
Awesome. Thank you.